Good morning, class. Happy Monday. I hope everybody had a great weekend. At this moment, I would like for you to have one last check of your cell phone before we begin class. I'll give you about 20 seconds. After you finish looking at your cell phone, I need you to copy your 2 learning targets down at the top of the paper, please. We have 2 that we're going to focus on today. Hope all y'all had a great weekend and happy Monday. 4 more days, spring break, 2K17. Okay, I'm ready to get started now. Put your cell phones away. We'll look at them again later on during our cell phone break. Alright, let's look at our first learning target today. What we're going to do today, we're going to start a new unit on sequences and series. It's not as bad as conic sections, I promise you. Actually, probably will enjoy this unit. This will be our last unit before we start our a unit about calculus, get you ready for AP Cal. So our first learning target today is I can write the first 4 terms of a sequence when given the general term. Alright, so starting off today, we're just talking about basically what a sequence is. If you see at the top of the page, it says an infinite sequence is a function. We're going to come back to what it means by being a function here, whose domain is a set of positive integers. The function value or terms of the sequence are represented by a sub 1, a sub 2, a sub 3, ... all the way to a sub n. Remember, those are ellipsis points. That means omitted material. That means it says that the domain is a set of positive integers. That means it goes from 1 to infinity. So at any given time, if you want to know the term, it's a sub 3, a sub 4, or it goes all the way to a sub n, whichever one you're referring to at the time. Now, this is called an infinite sequence because it keeps going and going and going and going. Now, let's talk about a sequence in terms of a function. Okay, you know that we've worked with all different types of functions this year. And you know, in a sequence, there's some type of rule. And that rule is usually in the form of an equation. Let's say that we had a sequence 1, 3, 5, 7, 9, so forth, so forth. Okay? We know that we're going from this term to this term, we're increasing by 2. So we can write an equation or expression to represent that. Y equals x plus 2. I put 1 in for this term. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7, and so forth. So here is a function to represent the rule for that sequence. So that is where this word function, whose domain. Remember, the numbers you put in is your input. The numbers you get out is your output. So you put in your x values and getting the y values. So that's how it's in terms of a function. Next, it says sequences whose domains consist of only the first so many positive integers are called finite sequences. Okay? Finite sequences just means they stop after a while. I mean, you don't have them keep going like you have an infinite. Those terms keep going and going and going. Finite, they stop after a certain point. So, going back to our first learning target, it says I can write the first 4 terms of a sequence when given the general term. Okay, now, this is the first examples here. Write the first 4 terms of the sequence when given whose general term is given. This general term is like your rule. How are you getting from one term to another? So, before we start with number 1, though, I want you to talk about what does a sub 1, a sub 2, a sub 3, and all that means. When you have a letter like A with a sub number 1, that means your first term, second term, third term. So when this right here says a sub n equals 3n plus 4. So it says at any given time in the sequence, for whatever term you're trying to find, let's say you're finding the first term, you'll plug 1 in to get that. Let's say you're finding the 16th term, a sub 16, that means 16th term, you'll plug a 16 in there. So I'm trying to find the first 4 terms, so I'm going to start off by finding a sub 1. A sub 1. I'm going to plug 1 in there, and I get 7. So my first term of this sequence would be 7. Alright, now I'm going to find the second term. I find the second term to be 10. Plug in a sub 3, that's your third term. Plug in 3 for your variable. That will give me 9 plus 4, which is 13. And my fourth term will be 16. It's not hard at all. It's just thinking of sequences throughout your career of elementary, middle school, and even early high school. You knew sequences as just numbers, and you found the secret pattern. Well, now you think of it as term of functions. Say there's your function, and that's how you get your values. You plugging it in. So let's look at number 2 here. That's a little more complicated, but don't let that intimidate you. I'm going to plug a sub 1. And I get the first term to be negative 1/2. Remember, raising a negative number to an odd power will remain negative. 3 raised to 1 is 3. 3 minus 1 is 2. Do you have to show all this work? Yes. A sub 2, I'm going to plug that in. Negative 1 squared is 1. 3 squared is 9 minus 1, which is 8. The third term of this sequence negative 1 cubed will be negative 1. 3 cubed is 27 minus 1 is 26. And the fourth term negative 1 to the 4th power would be 1. Three to the 4th is 81. 81 minus 1 is 80. Take a moment to look at that to make sure you don't have any questions. Remember, still no cell phone time at this moment. Okay, what I would like for you to do now is, please pause the video for just a minute, and I would like you to take like 3 or 4 minutes, and I would like for y'all to try number 3 on your own before I go over number 3. So at this moment, please pause it, and then I will go over it. Okay, welcome back. I hope that you had time to figure out this problem. I hope it didn't cause you much trouble. So let's look at this one. A sub 1. You plug 1 in, you would get 2 over 5 as your first term. A sub 1 means the first term of this sequence. A sub 2, I'm going to plug 2 in. And you get 4 6, which reduces to 2/3. A sub 3, I plug that in. I get 6 7ths. And A sub 4, you get 8 over 8, which is equal to 1. Double check my math. Let me make sure I did that all correctly. While you're checking that, you can get your cell phone out for just a second and have a quick cell phone check before we continue on. And remember, I will be back tomorrow if you have any questions on this first learning target. All right, guys, put your cell phones back away. Cell phone breaks over. Next, we're going to move to the next learning target. Let's read this one. I can evaluate a factorial expression. I can evaluate a factorial expression. This is something new to you. I do not know if this was covered in middle school. It used to be like years ago, but I don't know if it's still there. I do not think so. But we're going to learn something new called a factorial notation. Factorial notation. All right. And yes, you see correctly, there's an exclamation point there. There is a symbol in math class called, this is not an exclamation point. It looks like one. You draw it like one, but it's actually called factorial notation. So let's talk about what this means. When you see something that says 5 factorial, all that means is you're multiplying. You start at the number it is, 5, and you go all the way back to 1 and multiply those numbers together. It's very simple, I know. It's something you need to be aware of, though. So here we go. 5 factorial, you say 5 times 4 times 3 times 2 times 1. And you get 120. That is your value for that expression, 5 factorial. Now, I'm going to show you where this is on the calculator if you want to check, because you still got to know how to do it both ways, because I require you show your work. You will have to show your work on that. But find the factorial button. First you hit 5 and go to math. Go to this math button right here. And you're going to scroll over till you see the word P-R-O-B. That means probability. This is part of probability. And you're going to scroll down till you see the number 4. Hit it. Then go back and hit enter on your calculator. And voila, there's 120. So you can use, you can do it either way. So let's do 9 factorial. I'm going to still do it the old-fashioned way to make sure you understand the definition. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And yes, your value is 362,880. Those are the easy ones, understanding the definition of what a factorial is. Now, let's look at number 6 there. We've got a lot going on there. In the numerator, we have 10 factorial. On the bottom, we have 2 factorial times 8 factorial. That does look overwhelming, but you're going to be able to cancel something out in just a minute. So watch what I do here, and then I'm going to come back and explain it to you. I'm going to rewrite this as 10 times 9 times 8 factorial. Okay? And the reason I'm doing it is, watch this. Do you see that 8 factorial on the bottom right there? Well, right here, I didn't change the meaning because I said 10 times 9 times 8. I started the 10 factorial, but I stopped at 8 factorial because 8 factorial is part of 10. So that's why you can stop right there. And you see, I canceled those out. So really now, guys, 10 times 9 is 90. And you know 2 factorial is just 2 times 1. Because you start from where you begin and go all the way back to 1. So you got 90 divided by 2, not 20, I'm sorry. 90 divided by 2, which is 45 is your value. Okay? So remember, when you have a number factorial, you start where you go and you multiply all the way back till you get to the number 1. Alright, let's look at number 7. It's a little bit different. You see some variables in there with factorials. But it's really simple, so don't let it overwhelm you here, okay? Now, n plus 1 factorial over n factorial, okay? You know you're going to start from where you began and work your way back. Okay, so let's relate it to this number up here. 5, and then 1 less became from after 5. Well, if you had n plus 1 factorial, you're going to start off by saying n plus 1. If I go from 5 to 4, I reduced it by 1. Well, guess what I'm going to do here? If I reduce this by 1, I just have n, don't I? Well, look at the bottom right here. I have n factorial. So I could put a factorial there, put a factorial there, and guess what? You cancel those out, and you're left with just n plus 1. n plus 1. That's pretty neat. I like that problem. Start. because you're going to see something like that in the future. All right, moving on to number 8. And this is the one I'm going to start with tomorrow. I'm going to save this one, number 9, when I come back tomorrow, because it's a good problem. I want to be in class to share that with you, because that might confuse you just a little bit. All right, 14 factorial. Okay, let's see what we got. 14 factorial and 11 factorial. Well, I want that 11 to cancel out. So what I can do is write this 14 times 13 times 12 times 11 factorial all over 2 factorial times 11 factorial. That allows me to cancel those 11 factorials out. And then I have 14 times 13 times 12 all over 2 times 1. Okay, I'm going to calculate the math. Divided by 2, and I get a value of 1,092. And that would be my value there. Okay? And that is what you're going to be practicing today while I'm gone. I think you can handle this while I'm gone. Tomorrow we're going to pick up with number 9 and then move on to, I'll give you a second to look at that and make sure you got everything copied down. And then tomorrow we will move on to one of my favorite things, summation notation. You need to be aware of what this means, and just remember keyword sum is in summation because it has to deal with addition. You're going to see that tomorrow. So at this time, what you're going to do is practice what you just learned for the remainder of the period. And what I want you to do is turn to page 7. Page 7. And I want you to do numbers 1 through, I want you to do 1 through 10. I want you to do numbers 1 through 10. And I know that you probably still have about 40. No, you don't have that much time. You probably have 30-something more minutes. I know that won't keep you busy for the whole time. So after you get finished with that, I want you to look in your bell ringer section of your notebook. I gave you a new ACT packet. I want you to work on numbers 1 through 25 after you finish this. So after you do page 7, numbers 1 through 10, I will check this for a homework grade tomorrow. I also want you to do ACT prep numbers 1 through 25. And I know some of y'all will go super fast through your ACT prep. Make sure that you're on working, taking it very seriously. If you finish those 25, you can continue working on to your advantage. Keep working on, but you will not have no homework if you get 1 through 10 done tonight. Okay, I'm 1 through 10 today at class. I hope you have a great day. Have a great Monday. I will see you tomorrow. Thank you.